In this practice, show the following equations. We need to calculate the square norm of the Legendre functions. So we use the Rodriguez formulas to prove that these formulas. So minus 1 to the 1 p sub n squared dx is equal to, we use the Rodriguez formulas, 1 over 2 to 2n factorial of n squares minus 1 to the 1 n's derivatives x squared minus 1 to the n and the n's derivatives x squared minus 1's n's dx. So we use the Rodriguez formulas. P sub nx is equal to 1 over 2 to n factorial of n's derivatives x squared minus 1 to the n's. This is Rodriguez formula. Then we just only consider this part. This part is equal to the, we apply the integration by part many times. So first case is n minus 1's derivatives, n's, and the n's derivatives, minus 1 to the 1's, minus 1 to the 1's, the n minus 1's derivatives, and the n plus 1's derivatives. Then first term is exactly equal to the 0. Then we apply the integration by part to the second terms. This is minus 1, n minus 2 derivatives, n plus 1's derivatives, minus 1 to the 1's, n minus 2's derivatives. Then integration by part, so it becomes n plus 2's derivatives. First terms, again, it becomes 0. So it becomes minus 1 squares, d to the n minus 2's, n plus 2's derivatives, dx. So if you keep applying n times integration by part, so you can easily imagine this is minus 1 to the n's, minus 1 to the 1's, x squared minus 1 because of the n's derivatives, times d to the 2n dx 2n x squared minus 1 to the n's dx. You keep applying, then this terms exactly equal to factorial of the 2n. Then if you put inside of this, it becomes factorial of the 2n integral minus 1 to the 1's, 1 minus x squared to the n's dx. From this part, we change these terms. Is a factorial of the 2n minus 1 to the 1's, 1 minus x to the n, 1 plus x to the n dx. Then we apply the integration by part again. So this factorial of the 2n integration by part is a minus 1 over n plus 1, 1 minus x to the n plus 1, 1 plus x to the n, minus 1 to the 1. Integration by part is n over n plus 1, minus 1 to the 1, 1 minus x to the n plus 1, 1 plus x to the n minus 1. Then first term is becomes 0, n over n plus 1. Then again we apply the integration by part for the second terms. It's a minus 1 over n plus 2, 1 minus x to the n plus 2, 1 plus x to the n minus 1, minus 1 to the 1, plus n minus 1, n plus 2, minus 1 to the 1, 1 minus x to the n plus 2, 1 plus x to the n minus 2 dx. Then again, first term becomes 0. Actually, we have a factorial 2n, n times n minus 1, n plus 1, n plus 2, minus 1 to the 1s, 1 minus x to the n plus 2, 1 plus x to the n minus 2 dx. Then we keep applying the integration by part n times factorial of 2n, n times n minus 1, blah blah blah, up to the 1, over n plus 1, n plus 2, blah 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 blah, up to the n plus n, minus 1 to the 1, 1 minus x to the 2n dx. Then you can express factorial of 2n, factorial of the n, and if you write under this is a factorial of 2n, then you can multiply the factorial of n, and then this part you can integrate minus 1 to the 2n plus 1, 1 minus x to n plus 1, minus 1 to the 1. This is going to be cancelled out. So it becomes factorial of n squares over 2n plus 1 times 2 to the 2n plus 1. Then finally minus 1 to the 1 square norms of the Legendre functions is expressed 1 over 2 to the 2n factorial of n squares. Then you can substitute these quantities. Factorial of n squares over 2n plus 1 times 2 to the 2n plus 1. Then factorial of n square is going to be cancelled out. And then this is going to be cancelled out. So it becomes 2 over 2n plus 1. Okay, so we could calculate the square norm of the Legendre functions. This is the answer to this practice.